Hello, my name is T. Kaushik Reddy from CSCP, and my roll number is 22951A0570. And my in nothing but design and analysis of algorithm. My topic for the AAT Tech Talk is algorithm design. So let's learn how the algorithm is designed in the generally how an algorithm is designed. So let's know who introduced algorithm first. So first introduction. The algorithm, how the word came. So the word algorithm, it was introduced by the Persian author Abu Jafar Muhammad Ibn Musa al-Khwarizmi, he wrote a textbook on mathematics, and this word, he has taken the word on the special significance in the computer science, where algorithm has come to refer to a method that can be used by a computer for the solution of a problem. So he took an algorithm. So he took the word algorithm as it come to refer to method that can be used to solve that is used by a computer to solve a particular problem or the solution to find a solution for a particular problem. So this is what makes an algorithm different from words such as process, technique, or that. So algorithm is a totally different word from compared to other words such as process, technique, or a method. So basically, algorithm is used for getting the solution. It is used by the computer for getting the solution of a problem. So next, how the properties of algorithm. So there are 5 properties of the algorithm that are input, output, definiteness, finiteness, and effectiveness. So an algorithm is a finite set of so what is exactly the algorithm means? So algorithm is a step-by-step process. Generally, the algorithm is a step-by-step process. Or you can say an algorithm is a finite set of instructions that, if followed, accomplishes a particular task. So if it is a finite set of instructions, then the instructions are not infinite. So the number of instructions you give should be finite. It means countable. So an algorithm is a finite set of instructions that, if followed, accomplishes a particular task. In addition, an algorithm must satisfy all the following 5 properties or the criteria that are input, output, infiniteness, finiteness, and effectiveness. So input, 0 or more quantities are externally supplied. Next, output, at least one quantity is supplied. So input, you can do zero input or more than 0 inputs, but the output should be only one. At least one quantity should be purchased. It can be more also. Okay. Next, definiteness. Each instruction is clear and ambiguous. Means the instructions you give must be clear without any errors. Next, finiteness. If you trace out the instruction of an algorithm, then for all cases, the algorithm terminates after a finite number of steps. So finite means the number of instructions you give. It depends on that, and it terminates after the finite number of steps. So it is finiteness and effectiveness. Every instruction must be very basic so that it can be carried out in principle by a person using only a pencil and a paper. It is not enough that each operation be definite as in the criteria. It also must be feasible. Next, various steps to plan an algorithm. So there are various steps how the algorithm is planned or how algorithm is designed. So following steps that are devise an algorithm, validate algorithm. Sorry, it's not device, it's design an algorithm or devise an algorithm or validate algorithm. So let's look about the devise an algorithm or design. So creating an algorithm is an art in which maybe never be fully automated. When we get the problem, we should first analyze the given problem clearly. Means if you get any problem about the program, so you first analyze, then write down some steps on the paper. Next, validate the program algorithm. Means once an algorithm is devised or revised, it is necessarily to show that it computes the correct answer for all the possible legal inputs. Means validate algorithm. You have to validate the algorithm. Means when it computes, it should give a correct answer for all possible legal inputs. Next, the process is known as algorithm validation. Next, analyze. How you analyze an algorithm. So first, as an algorithm is executed, it uses the computer's central processing unit like CPU to perform operations on its memory, both immediate and auxiliary. To hold the program and data analysis of an algorithm or performance analysis refers to task of determining how much computing time and storage an algorithm requires. So you are analyzing the algorithm is nothing but you have to analyze the algorithm, that how much time it takes and how much space it takes to get executed. So time like you can set time complexity. To analyzing algorithm is nothing but to finding the time complexity and the space complexity of an algorithm. Next, test a program. Testing a program consists of two phases, that is debugging and performance management. So first, what is debugging? So the testing a program consists of two processes. One is debugging and performance management. First, debugging. Debugging is a process of executing programs on sample data to determine whether results are incorrect. If so, corrects them. So debugging is a process of executing, and if any if any errors or the incorrect and happens, so it corrects it. Next, performance management. Performance management is a process of executing a correct program on a data sets and measuring the time and space it takes to complete the results. So performance management is nothing but checking the time and the space it takes to complete the results, the algorithm. Next, design techniques. So there are various design techniques for the algorithm. So in my view, some algorithm designs are dynamic. Some algorithm design techniques are dynamic design technique, divide and conquer, branch and bound, static, etc. So first, let's learn what is divide and conquer approach. So it is top-to-down approach. The algorithms which follow the divide and conquer techniques involve 3 steps. So there are 3 phases in the divide and conquer. First, divide means divide the input into the sub inputs or a sub problem, or divide a problem into sub problems, so that it will be easier you to get solve it. So divide the original program into sub problems, or divide the input. So solve every sub problem individually recursively. So solve each every sub problem or the input you divided, and combine the solution of the sub problem top level into a solution of the whole original problem. Next, greedy technique is also one of the design technique of an algorithm. So greedy method is used to solve optimization problem. An optimization problem is one in which we are given a set of input values which are required either to be maximized or minimized. That is some constants. So greedy method is used to solve the optimization problem. So the optimization problem, it involves a given set of inputs which should be required and either to be maximized or the minimized. So greedy algorithm always take the choice. Greedy criteria looks best at the moment to optimize a given objective. The greedy algorithm does not have any guarantee the optimal solution. However, it generally produces a solution that is very close in the value to the optimal. Next, dynamic programming. Dynamic programming is a bottom-up approach. We solve all the possible small problems and then combine them to the obtain solution for bigger problems. So dynamic programming is nothing but it's a bottom to top approach where we solve the small problems and then combine them into obtain the solutions for the bigger programs or the problems. This is particularly helpful when the number of copying sub-problems is exponentially large. Dynamic programming is frequently related in optimization problems. Next, branch and bound. In branch and bound algorithm, a given subproblem which cannot be bounded has to be divided into at least 2 new restricted subproblems. So in branch and bound algorithm is a given subproblem which cannot be bounded, has to be divided into at least 2. Okay, at least 2 new restricted subproblems. So already divided subproblem should be if it is not bounded, it should be again divided into at least 2 restricted subproblems. So branch and bound algorithms are methods for global optimization in non-convex problems. So branch and bound algorithm can be slow. However, in the worst case, they require effort that grows exponentially with the problem size. But in some cases, we are lucky and method coverage with much less effort. Next, a randomized algorithm. A randomized algorithm is defined as algorithm that is allowed to access a source of independent, unbiased bits, and it then allowed to use these random bits to influence its computation. So randomized algorithm is nothing but using the random bits or to influence its computations. Next, backtracking. Backtracking algorithm tries each possibility until they find the right one. So backtracking algorithm tries each possibility, tries each and every possibilities which are possible and find the right. So it is depth first search of the set of possible solutions. During the search, if an alternative does not work, then backtrack to the choice point, the place which presented different alternatives and tries the next alternative. Randomized algorithm again. So basically, a randomized algorithm uses a random number at least once during the computation making a decision. So the randomized algorithm is nothing but the usage. It's random. So example one is in Quicksort using a random number to choose a pivot element or a pivot element. Next, as we know, in Quicksort we use the pivot element as the key element, and then we compare it with the all other elements. Next example to trying to factor a large number by choosing a random number as possible divisors. Next, algorithm specifications. So the specifications are the following are the algorithm specifications. Comments begin with the / and continue until the end of the line. Blocks are indicated which with matching braces, that is flower bracket, and identifier begins with a letter that data types of variables are not explicitly declared. Compound data types can be formed with records. Here is an example: node is equal to record. So open bracket, data type 1, data 1, and so on. Data type n, data n, number of data types you can include. Next, node star link is closed to flower bracket. Next, here a link is the pointer to the record type node. Individual data items of a record can be accessed with the side arrow and period. Input output are done using the instructions read and write. There is only one type of procedure algorithm. The heading takes the form. Algorithm name parameter list. Example algorithm max a comma n. A is an array size of n. Result is equal to array of L or 1. Then for I is equal to 2 to n. Then array of I greater than result. Then result is equal to array of I. Return result. So examples. There are two examples. One is sum of two elements, and the other one is the matrix multiplication. So algorithm sum is S is equal to 0 for I is equal to 0 to n. S plus is equal to S plus A of I, and nothing but array of I, return S. Then matrix multiplication, algorithm multiplication A, B, C, M, and P. For I is equal to 1 to M to do. For J is equal to 1 to N to do. Here we use do keyword, and for do while loop we use here. For K is equal to 1 to P T0. Next, C of I of J is equal to A of IK star B of KJ. So examples of recursive. Algorithm R sum A comma n. If n less than or equal to 0, then return 0.0 else. Return R sum A comma n minus 1 plus A of n. Next, algorithm add item, open bracket. If top greater than or equal to n minus 1, then open bracket right stack is full, return false, close bracket else, open bracket top is equal to top plus 1, stack top is equal to item, return true. Next, advantages of an algorithm. Effective communication. Since it is written in a natural language like English, it become easy to understand the step-by-step delineation of a solution to any particular program. Next, easy debugging. A well-designed algorithm facilitates easy debugging to detect the logical errors that occur inside the program. Easy and efficient coding and algorithm is nothing but a blueprint of a program that helps to develop a program independent of programming language. Since it is a language independent, it can be easily decoded in cooperating and any high level language. So yeah, thank you. This is my topic for design analysis of an algorithm. A subject. The topic name is analysis of different analysis of algorithm. Yes, thank you. Yeah, thank you.